Good morning, learners. Welcome to Backslides Online Secondary School. This is your space where you learn the sciences, namely physics, chemistry, biology, mathematics, agriculture, and other on-demand subjects. We continue with our revision sessions. Remember that this month is the month of revisions with focus on mock papers. So we shall do this up to the end of this month. Let me urge you to take advantage of this period, revision period. To master the key tips, examination tips as we present them to you in different papers that we bring to you. This is Chemistry Paper 1 from Blantyre Secondary School, BSS. If you are watching us on our YouTube channel, consider subscribing to the channel and you also hit the notification bell so that every time a new lesson is uploaded, you are informed on time. Welcome, learners. So without wasting your precious time, let's get down to the business of the day. We are revising Chemistry Paper 1 from Blantyre Secondary School. This is their mock paper, the 2026 mock exams paper. Having gone through it, I can affirm the fact that the paper is rich in exam style questions. That's why I felt compelled to revise this paper with you. Welcome, learners. My name is Mr. Paul Chilola once again. Welcome to section A. Number 1, give any two methods of disposing laboratory waste. Give any two methods of disposing laboratory waste. Remember, to dispose waste means to get rid of them. To get rid of waste from where they are generated, mostly the chemistry laboratory. There are numerous ways of getting rid of waste or disposing of waste. But the question is simply asking you to state any two, give any two for 2 marks. So out of the many methods of disposing laboratory waste, you're asked to name just 2. So among the many methods we have for disposing laboratory waste, we have recycling, incineration, normal waste bins, use of special controlled containers, draining using a lot of water, dumping, and landfills, just to name a few. But from this list, you're asked to give any two. So make sure you know all of them so that you can give any two when required by this question, and indeed when required by your MSCE exams, which are 20 days away. Welcome, learners. Describe how hydrogen gas can be tested in a chemical reaction. Some chemical reactions produce gases, and one of the gases produced is hydrogen gas. So how can you confirm that the gas produced by a chemical reaction is indeed hydrogen gas? Two marks. So the two marks come from statement of what you do, and then the other mark will come from the result, the expected result. So describe how you can test for hydrogen gas. So in order to test for hydrogen gas, you introduce a burning splint. A burning splint is like a stick, like matchstick, which is burning. So bring it over the mouth of the gas jar containing the gas. So the gas is going to burn with a squeaky pop sound if it's hydrogen. So 1 mark for saying introduce a burning splint at the mouth of the gas jar containing the gas. 1 mark. The other mark comes from the result that would be observed. So the gas burns with a squeaky pop sound if it's hydrogen gas. Welcome, learners. Welcome to Black Slides Online Secondary School. Consider subscribing to the channel. Invite your friends, wherever they may be, to revise with us. Remember, our goal is to produce as many distinctions in the sciences as possible. Welcome, learners. 1C, describe any two chemical properties of alkanals. Recall that alkanals are oxycarbon organic compounds. Alkanals and alkanones share something in common. They both have an oxycarbon as their functional group. They only differ in terms of their structures. So be careful here. We are asked to describe the two chemical properties of alkanals. Make sure you are describing the properties in relation to alkanals, because if you are not careful, you may end up describing the properties of alkanones. So welcome, learners. Alkanals burn in the air to form carbon dioxide and waters. In other words, alkanals undergo combustion reaction. They burn in oxygen and react with oxygen to produce carbon dioxide and water. That's one chemical property. They are easily oxidized to alkanoic acids. Under controlled conditions, they can be oxidized with a suitable oxidizing agent. They can form alkanoic acids. They can also be reduced to primary alkanols. In this case, we are looking at reduction as the addition of hydrogen to the substance. For example, if you take ethanol, which is an alkanol, add hydrogen to it, you may end up forming ethanol, which is an alcohol. Welcome, learners. They are also neutral to litmus paper. If you dip red litmus paper or blue litmus paper in an alkanol, there will be no color change. In other words, alkanols are neither acidic nor basic. They are neutral. They also participate in chemical reactions called the addition polymerizations. So identical molecules of alkanols can join with each other to form long chains, which is addition polymerization of alkanols. Welcome, learners. Give two uses of alkanols. So having stated the chemical properties of alkanols, now we are asked to state or to give two uses of alkanols. Before that, let's look at the distribution of marks. It doesn't mean that you should mention all these, no. By saying they burn in the air to form carbon dioxide and water, that's 2 marks. So they burn in the air, 1. To form carbon dioxide and water, that's another mark, so that's 2. They are easily oxidized, 1. To alkanoic acids, that's another mark, so you have 2 there. So by just writing these 2 points, you already have 4 marks. After all, the question is saying describe any 2 chemical properties. So it doesn't mean that you should mention this, then you should mention this, then you should mention this. No. Each point is 2 marks because each point has 2 parts and each part is 1 mark. So be careful with the allocation of marks and what the question demands. Give 2 uses of alkanols. Alkanols are used as preservatives. You can use an alkanol such as formaldehyde, also called methanol, to preserve biological species, rather specimen. So one of the uses of alkanols is to preserve biological specimen. The majority of the alkanols are used as solvents to dissolve other organic compounds. There are some alkanols which give sweet smell. They give very good aromas, so they can be used as perfumes. As perfumes. As mentioned above there, they can also be used in polymerization. Number 2, define the term molarity. We define molarity as simply the number of moles of solute which is dissolved in 1 cubic decimeter of a solution. So the number of moles of a solute dissolved in 1 cubic decimeter of a solution. That's called molarity. Or you can say the number of moles of a solute dissolved per unit volume of a solution. It's the same. Welcome, learners. Number 2b, a 0.9 gram tablet of a drug with a molecular formula of CnH8O was completely dissolved in 10 mL of water. Calculate the molarity of the solution. So what we are given here, we are given mass. We are also given the molecular formula of the compound and the volume of the water to be used. So for us to calculate molarity, first we must know how many moles of the tablet we are dissolving. So the number of moles is not given directly, but we are given the mass of the tablet. So number of moles, first of all, the first thing you need to do is find the number of moles. Number of moles is equal to the given mass divided by the molar mass of the compound. So substituting into the formula, the mass is 0.9 grams. The molar mass can be calculated from the given formula and the rams of the atoms making up the formula. So substitute, the mass is 0.9 grams. The molar mass is obtained by simply taking the total mass of the molecule CnH8O. So we take 9 multiplied by 12. 12 is the mass of each carbon atom in grams. So you have 9 times 12, and then 8 times 1. 1 is the mass of one hydrogen, and we have 8 of them there. So we multiply 8 by 1, then add 16 grams. 16 is the mass of a single oxygen atom. We are using these values given here. So if you do your calculation correctly, you should be able to get 0.0068 moles. Let me ask you to verify this with your calculator. Make sure that it comes to 0.0068 moles. So this is the number of moles that have to be dissolved in 10 mL of water. Now we come to the calculation of molarity. Now that we know the number of moles and we are told the volume of the water to be used to dissolve this number of moles, we shall use the formula molarity is equal to number of moles divided by volume. We have to be careful though. The volume here has to be in cubic decimeters. So you shall need to convert 10 mL of water to cubic decimeters by simply dividing this by 1000. So just bring this number of moles down here, that's 0.0068 moles, and divide by the volume. The volume is 10 mL. So 10 mL divided by 1000, it will give you 0.01 cubic decimeters. Dividing 0.0068 by 0.01 will give us 0.68 molar. Put capital letter there as the unit of the molarity, molar. So this is going to form a 0.68 molar solution of the drug. Let's distribute the marks by stating the formula for finding number of moles, that's 1 mark. By finding the number of moles there, that's another mark. That's how this question was graded. So we cannot say here 1 again, because that may mean that we shall have more marks than 4. By writing down the formula for molarity, that's 1 mark, and finding the final answer is 0.68 is also 1 mark, so a total of 4 marks altogether. Welcome, learners. Make sure you remind yourself of the formula used here. This is Black Slides Online Secondary School. Define reduction in terms of oxidation number. In terms of oxidation number, reduction is defined as the decrease in the charge or the decrease in the oxidation number of a substance. That's reduction. The opposite of reduction is oxidation, which is an increase in the charge or oxidation number. Welcome, learners. Calculate the oxidation number of chromium in chlorate ion. This is a chlorate ion, dichlorate ion. All right, so we shall apply one of the rules of oxidation numbers, assigning oxidation numbers, that says that in a complex ion, like this is a complex ion, polyatomic ion, this is a polyatomic ion, we have chromium and oxygen combined. The sum of the oxidation numbers is equal to the charge on the ion. So in this case, we have 2 chromium ions here. So we take the oxidation number of the 2 chromium ions. Since there are 2, we multiply by 2, plus 7 multiplied by the oxidation state of oxygen, which is minus 2. This is equal to minus 2 up there. The oxidation state of oxygen in any compound except peroxides is minus 2. So multiply 7 by minus 2, add the result to the oxidation state of chromium, which are 2 of them, and equate this to minus 2, which is the charge there. Simplifying this will give us twice the oxidation state of chromium, minus 14, which is 7 times 2, is equal to minus 2. Solving for chromium, twice the oxidation state of chromium is equal to 12. Minus 14 taken to this side, it will be 12. Divide through by 2. Dividing both sides by 2, it will give us the oxidation number of chromium as positive 6. So the oxidation state of chromium in this compound or polyatomic ion is positive 2. I mean positive 6. I beg your pardon. Let's distribute the marks. So the marks would come from the first statement here, substituting correctly, writing this equation, 1 mark. Simplifying this, 1 mark, and then finding the oxidation state of chromium is also 1 mark, so a total of 3 marks there. Welcome, learners. Back to the molecular formula. You would appreciate that Q is an alkyl. This is an alkyl or aldehyde if you want. As a matter of fact, this is ethanol. And R is a ketone. Ketone, which is also called an alkanone. How do we know? It has a carbonyl group, and it has a methyl group on both sides. I mean, alkyl groups on both sides. So this is an alkanone. So we want to describe an experiment that can be done to detect an alkanol and alkanone. For marks. All right, when you are distinguishing the two, an alkanol and an alkanone, you use what is called tolerance reagent. So you add one drop of an unknown, in this case either Q or R, to 1 ml of the freshly prepared tolerance reagent. By saying this, you have 1 mark. Then observe any changes in the test tube. Observe any color changes in the test tube. So an alkanol, which in this case is Q, will form a silver mirror in the test tube in the presence of tolerance reagent. So silver mirror is the positive test for alkanol. But an alkanone, which is R, will give a negative result, meaning that a silver mirror color will not be seen in the test tube. So no silver mirror means no silver mirror will be formed, indicating that R is an alkanone. So by saying each of these points correctly, you have 4 marks. Draw and name all branched isomers of butene. Remember, butene is an alkene with a double bond. So we are asked to draw all branched isomers of butene. As a matter of fact, there are only 2 isomers that you can draw. Remember, the number of isomers of any compound depends on the number of carbon atoms. And the number of isomers you can draw is found by simply subtracting 2 from the number of carbon atoms. So butene has 4 carbon atoms. That means we can draw only 2 isomers. So the first one is going to be a straight chain. This one, which is called but1-ene. But1-ene. The 1 indicates that the double bond is on carbon number 1. So this is the first one. By drawing the isomer, the structure, that's 1 mark. Drawing another, stating what its name is another mark. That's 2. The other structure will be this one here. We have created a branch at carbon number 2. This branch is called methyl group. And because we have placed it on carbon number 2, the name is going to be 2-methyl. 2-methyl on position 2. We have placed a methyl group, 2-methyl prop 1-ene. Prop 1-ene. meaning that the parent chain has 3 carbon atoms. It's called propene. And the double bond is on position number 1. Still, we have maintained the position of the double bond there so that we show clearly that these are structural or branched isomers. So the first one is just the normal butene straight chain, and this one here is branched at carbon number 2 to make 2-methyl-prop-1E. So structure is 1 mark, name 1 mark, a total of 4 marks. Welcome, learners. My name is Mr. Paul Chilola, your teacher. Figure 1 shows a flow process of electrolysis of dilute sodium chloride. I beg your pardon, this is sodium iodide. Use it to answer questions that follow. So let's just familiarize ourselves with the diagram. We have a power supply here. Which one end is positive, the other one is negative. And this end is connected to a graphite electrode marked A. And then we have a syringe which is connected that end, and the negative end is connected to an electrode, graphite electrode marked B. And we have a solution here for sodium iodide. Name the gases produced at electrode A and B. So first of all, consider the type of electrode A is. Since this is connected to positive terminal of the power supply, this must be an anode. Remember, it is at anode where oxidation happens, where negatively charged ions will give up their electrons to form atoms of that element. So in this case, the negative ions that will be present are iodide ions. And the positive ions that will be available here will be hydrogen ions and the sodium ions. Of course, because it's dilute solution, it means there are also hydroxide ions. So the gas that will be formed at A is iodine. Iodine gas will be formed there. Iodine is reduced, rather oxidized. So the negative iodide ions will give up their electrons upon arriving there, and this will form iodine gas. While at the cathode, that's where reduction happens. So the positive hydrogen ions will be reduced to just hydrogen gas. So at B, you have hydrogen gas being formed there. Welcome, learners. My name is Mr. Paul Chilola, your teacher. Consider subscribing to the channel. In case you have questions, don't hesitate to send us a text message to these numbers, any one of them. We shall be able to come back to you with a response. Welcome, learners. Write half equation to show reaction at electrode A. We just mentioned that at electrode A, that's where oxidation happens. So the negatively charged iodide ions will give up their electrons to form iodine atoms or iodine molecules, since iodine is diatomic. All right, so this is what's going to happen. So the half equation to show the reaction there at the electrode at the anode. By the way, the statement has not told us that A is anode. We have just figured it out ourselves because A is connected to the positive terminal of the battery. Therefore, it's an anode. And the oxidation has happened there. This is the half equation. Give two examples of acidic oxides. Remember that acidic oxides are the oxides of nonmetals, nonmetal elements combined with oxygen. When you dissolve them in water, they form acidic solutions. The main examples you can give, the question is requiring just any two. Sulfur dioxide, SO2 is one example. Even carbon dioxide is also an example of acidic oxide. When you dissolve each one of them in water, you'll form acidic solutions. Nitrogen dioxide is another one. So just name Na2. All right, we are given here 3. Make sure you know these and the others. Define a conjugate acid. We define a conjugate acid as simply the product formed when a base accepts a proton. Remember that bases are substances that accept protons, which is hydrogen ions. In other words, bases are proton acceptors. So when a base accepts a proton, the resulting product is called conjugate acid. Take note, conjugate acid. So a simple definition of conjugate acid is the product formed when a base accepts a proton. Welcome, learners. The conjugate acid-base pairs of the chemical equation or chemical reaction are given here. Ammonium ions and the ammonia will form a pair. Water and the hydroxide ions will also form another pair. We are asked to write a chemical equation for the reaction. So first of all, we must figure out what is happening here. What is happening is that water molecule donates a hydrogen ion to ammonia to form ammonium. And in so doing, a hydroxide ion will remain. All right. Remember that conjugate acid-base pairs only differ with one hydrogen. Like this pair here differs with just one hydrogen. Ammonium has more hydrogen compared to ammonia. And the water has more hydrogen compared to the hydroxide ion. So our equation must show that water is donating its hydrogen ions or proton to ammonia to form ammonium and hydroxide ion. So such an equation is going to look like this. So ammonia, this is accepting a hydrogen from water to form ammonium. So when one hydrogen is donated to ammonia, a hydroxide ion will remain. So this conforms to the conjugate acid-base pairs given up here. Figure below is a diagram of part of the electrochemical series. Use it to answer questions 34. So the first equation is showing the reduction of iron ions to form iron metal. And this is associated with a standard electrode potential. standard EMF. This process happens at the cathode of the cell. Copper ions are being reduced to copper metal atoms, and this is accompanied by an electrode potential of 0.34. So this is just taken from the electrochemical series, and we are taught to use these values to calculate the standard EMF of the cell, this cell here. The left-hand side, this is called a bridge, salt bridge. The left-hand side of the cell shows oxidation. Iron is being oxidized, iron metal oxidized to iron ions. This must be at the anode of the cell. And the other side, copper ions are being reduced to copper metal. This must be happening at the cathode. So with the given values, we are asked to calculate the EMF, the standard EMF, the electromotive force, in other words, the voltage. So for this cell here, the standard electrodes are given. When iron is oxidized, rather reduced, this must be oxidation, oxidized, its EMF is 0.44. And when copper ions are reduced, the corresponding EMF is 0.34. So for this cell here, to find the standard electrode potential, electrode EMF, the standard EMF is simply going to be the EMF at cathode, where reduction is happening, this one, minus the EMF at the anode, where oxidation is happening, which is minus 0.44. So simplifying this, working this out, the EMF of the cell is going to be 0.78 volts. Don't forget the units there. Welcome, learners. We are asked to figure out whether the reaction is going to happen or not, giving a reason. The answer is yes, it's going to happen. This is because iron is more reactive than copper. That's why iron is above copper. So an element that is above copper is more reactive than copper. Therefore, that is going to displace, the iron is going to displace copper from its solutions. Therefore, the reaction is indeed going to happen. Explain how galvanizing prevents rusting. Remember, galvanizing is coating a metal with zinc, strictly zinc. So how does zinc, which is coated on a a metal such as iron protects the iron from rusting. 3 marks. The 3 marks are coming from the fact that when zinc is punctured, let's say there's a hole made on a zinc which is coated on iron. Water and oxygen, or water or oxygen occupies the gap, the puncture, the hole. The water or oxygen will cause the iron inside to start rusting, rather to release electrons. So this will force iron to ionize and become iron ions. This is AQ, not AG, it's AQ, ready to form rust. But what will happen instead is that immediately zinc will donate electrons to the iron in order to avoid unnecessary further rusting. By saying these points, you have 3 marks. So when zinc is punctured, water and oxygen occupies the gap. This will force the iron to ionize, meaning to lose electrons to form iron ions. This is aqueous, aqueous ion, ready to form rust. But immediately, instead of further oxidation, further rusting, zinc is going to donate 2 electrons to the iron ions in order to avoid further unnecessary rusting. 3 marks. Define hard water. We define hard water as simply water with high concentrations of calcium and magnesium salts. For example, you can have magnesium sulfate, calcium sulfate dissolved in such water. It will make it hard water. The simplest definition of hard water. Mention any 3 advantages of hard water. Hard water is not completely bad. It is very useful in some ways. So the question is saying we should state 3 of them, 3 advantages of hard water. Water that contains high concentrations of magnesium and sulfate, magnesium and calcium salts. Hard water helps in the development of healthy teeth and bones in people. When you drink such water, your teeth become strong. Your teeth and bones become strong because of the calcium part. Hard water helps in the formation of shells in animals such as the crabs, animals such as tortoises, snails have shells. So the shells become strong due to calcium found in water. Hard water also is helpful for healthy growth of plants in agricultural industries. Calcium and magnesium salts are beneficial in the growth of plants. Describe how boiling removes temporary water hardness. First of all, you must understand that temporary water hardness is one in which water which is temporarily hard is one that contains carbonates. It would be magnesium carbonate, calcium carbonate, or calcium hydrogen carbonate. The key word there is carbonate. Right, so how does boiling the water remove such water hardness, temporary water hardness? All right, so when the water is boiled, on boiling, the calcium carbonate, hydrogen carbonate, and magnesium hydrogen carbonate will decompose. to give calcium carbonate and magnesium carbonate. These two are insoluble in water. So because they're insoluble in water, they are going to precipitate out. So the insoluble particles will precipitate and separate out from the water, making the water soft, or making the water free from the salt. Welcome, learners. Question number 7. A polymerization of chloroethene can be represented by the equation below. So we have chloroethene combining chloroethene molecules combining with each other to produce a polymer. The question is, name the polymer formed. Polymer that has chlorine molecules attached to carbon atoms is called PVC. PVC is short for polyvinyl chloride. As a matter of fact, you will have to know that this is called vinyl. Chloroethene is called a vinyl. So we have many vinyl molecules combining to form PVC, or polyvinyl chloride. Take note, in polyvinyl chloride, we have chlorine as one of the atoms attached to the carbon chain. So the answer there is polyvinyl chloride, PVC short. What kind of polymerization is represented in the equation above? This must be addition polymerization. How do we know that? Because in addition polymerization, identical molecules join with each other to form long repeating units, long chain of repeating units. Addition polymerization. Explain why thermosoftening plastics, also called thermoplastics, melt when subjected to heat. When you heat thermosoftening plastics, they melt very easily, unlike thermosetting plastics. So the reason why this is the case is because the polymer chains in thermosoftening plastics are not cross-linked. They don't have cross links. All right? So because of that, when they're heated, their polymer chains will flow over one another, and the plastic as a result is going to melt. The key word here is the absence of cross links. There are no cross links in thermosoftening plastics, therefore, when heated, the polymer chains will flow over each other and then the plastic melts. Question number 8. Iodine and chlorine react according to the following chemical equation. Iodine reacts with chlorine to form iodine chloride. Given the bond energies below, calculate the net heat energy of the reaction. Remember, bond energy is energy required to either form or break a bond. So for us to break a bond between the iodine atoms, 151 kilojoules of energy must be absorbed to break this bond. To break the bond between the two chlorine atoms, 242 kilojoules of energy need to be absorbed. To form two molecules of iodine chloride, this amount of energy needs to be released. Remember that bond breaking is endothermic, while bond forming is exothermic. So we are asked to calculate the net heat energy, which is the same as the enthalpy change. Calculate the enthalpy change from this reaction, given this data here. So to calculate the net energy, we shall use the formula, the energy of the products minus the energy of the reactants. This is the enthalpy change of formation of that. It's going to be equal to the enthalpy of the products minus the enthalpy of the reactants. So look at the products here. We have 2 moles of this. That means the energy released, the energy change for the formation of 2 moles of iodine chloride will be 208 multiplied by 2, then minus the sum of the energy changes during the bond breaking in chlorine and the iodine. So just take 151, add 242. Simplifying and subtracting will give us the net energy of 23 kilojoules per mole. The sign in front of the answer here indicates that this reaction is endothermic. Remember that in an endothermic reaction, the enthalpy change is positive. Figure below shows structures of giant molecules of carbon A and B. Which structure does not conduct electricity? Explain. All right, so here we are asked to identify the structure which does not conduct electricity. Which one do you think will enable electric current to flow through? First of all, you must identify the names. This is basically diamond, and that's graphite. So structure A does not conduct electricity, but that's not enough for us to say. We need to explain why. So like I mentioned, structure A is diamond. This is diamond. In diamond, each carbon atom forms 4 covalent bonds with other carbon atoms. If you look at this carefully, you find that each carbon atom is bonded to 4 others. Each carbon is bonded to 4 other atoms. The effect that will have is that the valence electrons are used in bonding, so there are no free electrons to carry electric current, 3 marks. So by saying that structure A will not conduct electricity, and by explaining that each carbon atom is fully bonded to 4 others, that's 1 mark for identifying, and another mark for explaining the bonding in diamond, and then lastly for saying why it will not conduct. Carbon has the tendency to form up to 4 bonds with other atoms. So in a diamond, all the carbon atoms are bonded. Each carbon is bonded to 4 other atoms, leaving no free electrons to carry current. For that reason, A will not conduct electricity. So take note of that. Dry crystals of copper sulfate. Welcome, learners. So these stages, when fully discussed like this, will give you 4 marks. So by saying the first statement there and its equation, that's 1 mark. By saying this and the equation, that's another mark, that's 2. By saying this and the equation down here, that's 3 marks, and then the final statement, that's another mark to give you 4 marks. Question number 11. With the aid of well-balanced chemical equations, describe how sulfate, beg your pardon, this is sulfuric acid, is produced using the contact process. This is not sulfate acid. It's supposed to be sulfuric acid. Of course, sulfuric acid is a sulfate. Using the contact process. Remember that the contact process is the step-by-step procedure of making sulfuric acid. So we are asked to use the balanced equations, chemical equations. So the first stage is the production of sulfur dioxide, in which sulfur is burned in air to produce sulfur dioxide gas according to this equation. So sulfur in solid state is burnt in oxygen gas to produce sulfur dioxide, which is also a gas. The sulfur dioxide produced in step number 1 is converted to sulfur trioxide. So the sulfur dioxide is mixed with excess oxygen and passed over vanadium oxide, which is a catalyst, at a temperature of about 450 degrees Celsius and at an atmospheric pressure of 1 to 2. So sulfur dioxide produced up there will react with oxygen to produce sulfur trioxide. The sulfur trioxide produced in step number 2 is going to be dissolved in concentrated sulfuric acid to form what is called the oleum. Very, very important. So oleum is just a highly concentrated sulfuric acid, very concentrated. So for us to produce dilute sulfuric acid, what we need to do now is to dissolve or to dilute the oleum produced there in water to produce the desired product, which is called sulfuric acid. This one here. So make sure you know these equations, because the examiners would want you to use the equations, balanced chemical equations, to explain the contact process. So this is called the contact process. These are just conditions required. The process works best under these conditions, where vanadium is used as vanadium oxide is used as a catalyst, and a temperature of 450 degrees Celsius is desired. And also a pressure of 1 to 2 atm atmospheres. This is called the contact process. Welcome, learners. My name is Mr. Pochilola, your teacher on this platform. Lastly, for some reason, this paper has 12 questions. I think, unlike your paper, the MSCE paper is going to have 13 questions. So take note of that. So the teachers who formulated this paper, for some reason, gave or managed to come up with 12 questions. So the last question is saying, describe how a 300 mils of 0.1 molar sodium hydroxide solution can be prepared using a 2 molar sodium hydroxide solution. Take note, this is called dilution method, where you take a strong solution, a solution with high concentration, and add water to it to get a diluted solution. As chemistry students, you need to know the step-by-step process of doing that. So, the solution that we would like to make has a concentration of 0.1 molar, and our target is a volume of 300 mils. So let's call this, attach some variables to this. Let's call the initial concentration. Remember, this is the stock solution. The solution we have is 2 molar. Has concentration of 2 molar. Let's call this C1. And its volume, the volume that we need to get from this, let's call it V1. This new solution will have a concentration of C2, 0.1 molar, and a volume of V2, 300 mils. So we need it, therefore, to work out the volume of the stock solution that we need in order to make this new solution here. So we calculate the volume of the stock solution to be transferred using the formula C1 times V1 equals to C2 times V2. What are these things? C1 is the concentration of the original stock solution, in this case 2 molar. And V1 is its volume, the volume that we need to get from the 2 molar sodium hydroxide solution. We don't know it. That's the one we need to work out. So this formula is called dilution factor, dilution formula. So substituting, C1 is 2, V1 is what you needed to find. That's the volume of the solution, the stock solution we need. C2, which is the new concentration, is given as 0.1, and the V2 is given as the volume of the solution that needs to be made. In this case, 300. So solving for V1 will give us V1 equals to 15 mils. So we need to get 15 mils of 2 molar sodium hydroxide solution. We need to measure this carefully using a measuring cylinder, or we can use a pipette if there's one, an accurate instrument for measuring this one if we can, but there's no harm in using a measuring cylinder, a good one. You can also use a pipette. So this is the volume of the stock solution that we must get from the 2 molar sodium hydroxide solution. So measure out, having calculated this. By the way, you can do this calculation before you carry out any measurement. So measure out 15 mils of 2 molar sodium hydroxide using a measuring cylinder or pipette. If there is one which can measure 15 mils, a pipette, better, because a pipette is more accurate than measuring cylinder. We are describing how to prepare 300 mils of 0.1 molar sodium hydroxide solution from a stock of 2 molar sodium hydroxide solution. Welcome, learners. So measure the 15 mils of 2 molar sodium hydroxide solution using a measuring cylinder or pipette. You can use measuring cylinder if you don't have a pipette, but I would prefer to use the pipette because the pipette is more accurate. Then transfer the solution into a 300 ml volumetric flask if you have one. It is preferred that you use that. Okay, so transfer this solution, the 15 ml of 2 molar sodium hydroxide, into a volumetric flask of this calibration. Then you rinse the measuring cylinder with distilled water and transfer the water into the volumetric flask, this one over here. Once that is done, you add water to the flask up to the mark, the 300 ml mark. Then put a stopper and shake to mix well.